Okay, good day everyone. My name is Teacher Gab and today I'll be recording lectures for chapter 7 which is about geometry. So yeah, geometry usually about shapes, either 2D or 3D, as well as finding angles, finding measurements like volume, surface area, and so on. So yeah, for geometry, before I start the chapter 1, which is about plane figures, I will explain the different notations involving geometry. Like the first concept is point or like a dot. I'll write point. Sorry for my handwriting. For example, if you see a point here, we can name it as point A. And then another point here, we can name as whatever. Like for example, this would be named as point C. So yeah, first concept is point. Then next is line. Like for example, when you connect another point, which is point A and then point C, and you connect it with an infinite line, yeah, imagine those 2 points are connected. This is called line. And if those two ends are connected indefinitely, meaning it extends to a longer length, then it would be called line. Then here, we can name that line um, by looking at the name of the points we have here, point A and point C. Therefore, we can call it as line AC. Or we can write it like this and then AC. That is for line. So yeah, let me fix it first. Yep. Or if you look at their example we have here, line AB. Here, line AB. As you can see the figure here, there are 2 points, point A and point B, and then they are connected together. This is called now line AB. So yeah, continuous points extending indefinitely in both directions. Then next, what if we have a point? For example, we have point A and then point B. Let's name it point A and point B. But then they are connected by a line. But then that line starts with point A and then ends with point B. Like it's not indefinitely extending. It just stops at A, starts at A, and then ends in B. Now this is called line segment. So line segment here, it is the segment which consists of two endpoints, meaning A and B, and set of all points within them. Or yeah, when you see a line and then it starts with a point and then ends with another point, it's called line segment. Therefore, we can name this line segment as line segment AB. You see the difference between line and line segment, right? Let me write segment, line, segment. So yeah, we have point, line, and line segment. What if ray? Next concept, ray. So yeah, let's choose another point here and another point here. Let's say this it's connected by a line, but then one line is extending and one line starts at a point. Like for example, this is C and D. So we have a ray. Ray here means that part of a line that consists of endpoint A and then the set of all points on one side of endpoint. Meaning, here in the ray, as you can see, the line starts at a point and then it is connected to another point, but then it is indefinitely ending. The other end is continuous and then the other one is started at the point, meaning it is called ray. Therefore, we can name this point as ray, or we can write it as ray A, not A, C and D. Yeah. And then next, we already finished the point, line, and line segment, and ray as well. Let's define parallel and perpendicular. So yeah, first is about parallel. Parallel is defined as two lines in the same plane. Same plane meaning same, for example, this is plane or same surface. Like for example, there are two lines here. Let's make it diagonal. There are two lines here, and then this line is probably it is point A here, and then point B here, and then point C here, and point D here. Now we have two lines, line AB, line segment AB, and line segment CB. But then there are parallel. So parallel here means that two lines in the same plane that never intersect or will never meet together, because these are two straight lines in the same, but then they will not intersect, meaning they are parallel from each other. So parallel and parallel. Yep, we can denote it as this one and this line, and then we can denote it as line AB is parallel to line CD. You see, this is the symbol for parallel lines. The next, perpendicular line. So let's have two lines. Oh, straight line. And then another straight line. So let's say this point is point H, and then I, then the horizontal line point J, and then point K. And then you see they intersect with each other, and then they meet. And then as well they form a right angle. Like for example, right angle is usually denoted by this one. And then this one. And then it has 90-degree angle, 90-degree angle. Meaning here that line HI is perpendicular. Perpendicular, yeah, with this symbol. This is the symbol for perpendicular with line JK. So yeah, let's read the let's write first perpendicular. Sorry for the mess. Perpendicular. So here perpendicular is defined as when perpendicular lines intersect to form 90-degree or right angle. Yep, 90-degree here it is the measurement which is called right angle. 90-degree slash right angle. And then yep, we already finished line, segment, ray, parallel, perpendicular. So I hope you understand. Yeah, let's continue until we have here the degree, which is the measurement. Like for example, if we have line point A, then point B, then point C, A, B, C. And when you connect it together, you see that there's an angle forming here. So yeah, angle is the formed by two lines, segments, or rays that have the same endpoint. So here, the same endpoint in point A and point C is B. Therefore, which is called the vertex. So here, they had the same point B. Point B is the vertex. You see, because point A extends with point B, and point C extends with point B. And then we can name this angle as angle we can write it as angle ABC. And then, whatever the measurement, whatever degrees, like for example, it could be 45 degrees or whatever. So yeah, we can call it as x since we don't know about it. We can represent it by a variable. And then yeah. So yeah, we will call this as angle ABC. Meaning from point A to point B to point C, it creates an angle. Therefore, angle ABC. So I hope you understand. And then yeah, later we will cover all about it. And then yeah, that's it for the basic geometric notation. First is point, then line segment, ray, parallel and perpendicular, as well as angles. So yep. Next, we will now cover the chapter 7 of the GED mathematics, which is about about geometry. And then the first lesson is about plane figures. So, in your book, plane figures is defined as set of line segments or all lying on a single plane. And then, yep, for example, this is the plane. This is the plane. And then line segment. Do you still remember what is line segment? So for example, if there's a point A and then point B and then another line segment here and then another line segment here, if they're connected together, they can form a plane. So yeah, here another definition is 2D shapes with corners. So yeah, the common plane figures, we will start with rectangle. Obviously, you already know what a rectangle is. It is a four-sided figure with four right angles. So yeah, let's talk about angles. Obviously here, this is angle, which is 90 degrees, and then 90 degrees, then 90 degrees, then 90 degrees. And then, the opposite sides, the length of the opposite side is equals to each other. Like for example, okay, so if we have triangle with point W, X, Y, Z, the line WX is parallel to line segment YZ. So yeah, this is the WX and then YZ, and then you see they're parallel with each other, right? And then they have the same measurement. That's why we can note it with this line. And then another line segment WY is also parallel. WY is here, and then XZ parallel with line segment XZ. So yeah, that is for square. You see if they have the same marking, meaning they are equal. Like for example, this is equal with this equal. And then, yep, the degree is always, on the four corners is 90 degrees. 90 degrees. And then, you should remember, for the plane figures that we will discuss, all angles are equal to 360 degrees. So probably 90 times 4, 1, 2, 3, 4, is equals to 360 degrees. So yeah, that's it for the rectangle. I know you're familiar about it. Let's just discuss, okay? So next, square. So here, for example, we have square with points. Let's say this is L, M, N, O. So square here is defined, it's like a rectangle. But then it has four right angles with parallel opposite sides And then all lengths, all sides are the same. Like for example, yep, if this is 5 centimeter, this is also 5 centimeter, and this is also 5 centimeter, 5 centimeter. All sides are equal. And then it also has a 90-degree angle on all of its corners. So yeah, square, rectangle just the same, but then square is all sides are equal. The next, parallelogram. So yeah, parallelogram is a four-sided figure. Four-sided figure, there's two, three, four sides. But then, the opposite sides are parallel to each other. So yeah, parallel meaning, if we have a parallelogram A, B, C, D, so line segment AD is parallel to line segment AB. And then, yep, also the line segment AB is parallel to line segment BC. And then another feature is that all sides, all the parallel sides are equal. So meaning AB is equal to DC, as well as AD is equals to DC. But then it's also like square rectangle actually, but then the angle is not 90 degrees. How should I say this? Now, for example, this angle, this, and then this angle, and then this angle. So yeah, it's not 90 degrees. However, the total angle would always be equal to 360. So how many angles here? We have angle DAB. Yep, angle DAB. For example, this angle, and then what else? Plus angle ABC. Neat, this one. So plus angle BCD, this one, as well as angle CDA, angle CDA, this one. It would always be equal to 360 degrees. So it would be helpful if for example you don't know the angle of one side and then this side, but then you know the angle of this side, and this side, you can just add it all up and then subtract to 360 degrees. Then next, we have here another shape which is same with parallelogram. It's called rhombus. Rhombus. It is like a parallelogram, but then it's also like a square, meaning all sides are equal, but then the angle is not 90 degrees. That's why it is classified as a rhombus. You see the difference between parallelogram? The sides is not equal, only the parallels, and then but then in rhombus all sides are equal. So yeah, next is parallelogram and rhombus. And then next, trapezoid. So yeah, in your book, it says here trapezoid is a four-sided figure with one pair of parallel sides. Okay, one pair of parallel sides. Meaning, it's like a rectangle also, wherein it has parallel sides here and here, and then they are connected with legs. So this legs and this legs. Here another parallelogram wherein it has, for example, A, B, C, D. how should I say? S T U B. So yeah, for example, in trapezoid ABCD, line segment AB is parallel to line segment CD. And then in STUB, um, line segment ST is parallel to line segment UB. But then they are connected with legs. This is leg and this leg, this leg and this leg. So there are two types of trapezoid. First is isosceles trapezoid, wherein it is equal, like the sides here are equal. Whereas for non-isosceles, I hope you understand my handwriting. Trapezoid, the legs are not equal. You see? That's the difference between isosceles trapezoid and non-isosceles trapezoid. And then, yeah, that's it for the lesson 1 about plane figures. Again, first remember the following common terms about geometry, and then next, the common plane figures, which is rectangle, square, parallelogram, and trapezoid. So yeah, you can answer the practice questions here. You can refer to your book and answer by yourself. Then we will check it later. So yeah, that's it. This is for the lesson 1 of chapter 7, geometry, which is about plane figures. Thank you for listening.